Here you have the distribution, the global distribution of aerosol for the year 2012. And you see that in different area you have different amount of aerosol, which are indicated by colors. And the dust, which are emitted mostly in the deserts, okay, appear in red. And so here you have North Africa, and you have some front passing by with a wind acceleration, and then you have an uplift of these fine particles, which are then transported all the way to the Caribbean, depending on the period. In spring, it will mostly go to Europe. Then you have another aerosol, which are sea salt, which are coming from the splash of waves, which will free some bubbles, and when they reach the surface, they will release some sea salt particle, and they are indicated in blue. And where you have most of the strong waves is in the Southern Ocean here. Okay, and you see this, all this blue color. These are the sea salt aerosol. And also as you know, in Europe, you have, in UK, you have strong winds over the Atlantic, and you get this sea salt particle. These are what's called natural aerosol, so they are emitted mostly by winds. And then you have pollutants. Pollutants are particles which are formed from gas emitted by the industry, cars, and other fossil fuel burning. And so you will find them mostly industrialized regions, like in the United States, Europe, and East Asia and China. And they are indicated in gray. So you have all this white cube. These are sulfate particles which are formed after condensation and nucleation of gas compound, sulfur dioxide. Then you have another important aerosol, which are coming from fires, open fire, biomass burning of savanna or forest. And you can find them in tropical region where they burn practically every year during the dry season, all the savanna, and also in the tropical forest they burn the forest. And they are indicated in green here. And they are transported by the trade winds here, by the easterly to the Amazon. And you have fire in the Amazon, which are transported here towards the east. You have another region of biomass burning, South Africa, mostly during the dry season, which will be more in July, August. And you have a lot of biomass burning also in Indonesia, Java, and New Guinea, and also in northern Australia. So you have all these aerosols, which are either emitted naturally by winds or anthropogenically by the release of long chain of hydrocarbon or sulfur dioxide, and they will condensate and form some liquid or solid particle, and they are so tiny that they will be transported over very long distance by the winds. While they are in the atmosphere, they will interact with solar radiation. The size of this particle is of the order of 1/10 of an air diameter, and this is also where this corresponds to the wavelength in the visible. For the green, it's 500 nanometer or 0.5 micrometer, which is the size of the dust particle. So you can imagine that you have an interaction between the solar radiation and this aerosol. And they will absorb this solar radiation and scatter them. When they absorb this radiation, they will heat. And by heating, they will change the temperature profile. If you change the temperature profile, then you will change the dynamic, and the precipitation. So they have this effect on climate, precipitation, temperature, winds, through what's called the direct effect or the interaction with radiation.